Hey, Carolyn. Like I said in my email, I'm just going to go through most of the problems you mentioned in that email to give you an idea of how to set them up, and then you can just watch this video. I'll also send you links to my Taylor series and Taylor approximation videos, so you can look over those too. But as far as it goes, let's see. The first one, L is equal to the summation n equals 1 to infinity of 1 over 2 to the n plus the summation n equals 0 to infinity of negative 1 to the n over 2 to the n. Then what is L equal to? And I don't actually know if these are practice problems for the test or just practice problems you found or not, but you weren't clear in your email on that. But I'm going to assume that these are practice problems geared towards the type of problems you will see on the test you'll take to get out of taking Calc 2. So the point being, if the test is like multiple choice like these are, then there's kind of tricks more or less you can use to help you figure out what's going on. And then also the math things in general you should know. First off, if you want to find this sum right here, clearly the sum here and the sum here have to exist, and based on the solutions, they have to because your solution is a number. You understand, find the sum here and the sum here. These are both geometric, so just find their sum. If you can't just look at it immediately and figure out what's going on, remember the formula and plug in. And the other thing I will say, because I did it as an instructor in Calc 2, you took Calc 2 with me, I think. I'm not positive. But one of the things that's clear here, they mess with the indices to make sure you're paying attention. So it might actually be helpful to write out the first few terms to get an idea of what's going on. Meaning, if you do this one first, you start with it with n equal to 1. So you get 1 over 2 to the 1, which is 2, plus 1 over 2 squared, which is 4, 1 over 2 cubed, which is 8. Clearly that's geometric. This one right here, start with n equal to 0. Negative 1 to the 0 is 1, 2 to the 0 is 1, so you get 1. Negative 1 to the 1 is negative 1 over 2 to the 1, which is 2. Negative 1 squared is 1. 2 squared is 4. And then you get that. And that's also geometric. Here the ratio is 1/2. Here the ratio is negative 1/2. And again, that part, just looking at them, is clear, but for some of the geometrics, you need to know the leading term for the formula. So check the indices, because again, stuff like that is a deliberate math thing we do to make sure you're paying attention and understanding what's going on. So for the purposes of this, the summation, we'll go with S sub 1 just for that one, is the first term, which is 1/2, over 1 minus the ratio, which is 1/2. So it's 1/2 over 1 minus 1/2. 1/2 over 1/2 is 1. Here, we'll just call it S sub 2. The first term, which is 1, over 1 minus the ratio, which is negative 1/2. 1, negative 1/2, two negatives become positive, that's 3/2. Flip that, and you get 2/3. 1 plus 2/3 is 5/3. And I'm really gonna hope, hey, that's one of the answers. Cool, which tells you we did it right. Next up, let's see. We won't do this to an incredible amount of detail, but there's, again, an understanding here. The summation n equals 1 to infinity of 1 over n squared plus 1 to the p. Determine when it converges. And I would point out again, mathematically you'd be looking at, from Calc 2, one of the tests, either maybe a root test, maybe a comparison test. If your test is multiple choice, you can use an understanding here. Meaning, let p equal to 1. If p equals 1, that just becomes 1 over n squared plus 1. That's not a p, and this is where I mentioned like the different types of tests you can do. That is not a p-series, but you can compare it to the p-series because it's essentially 1 over n squared, which you know converges, which means this thing is going to converge, which means if p is equal to 1, it converges. If you look at the possible answers, The first one, p has to be greater than p is greater than 1, that's out. P is less than or equal to 1 for B, that's a possibility. P is greater than or equal to 1 for C, that's a possibility. Greater than a half, possible. Less than or equal to a half, not possible, because it works for 1. Which means you're down to B, C, and D to look at it. And I would point out, if you take P less than or equal to 1, then P could be negative. If P is negative, that flips this fraction, that goes into the numerator, and then it just becomes some polynomial that gets huge. Clearly it doesn't converge, which means P less than or equal to 1 also doesn't work. So your only options are greater than or equal to 1 or greater than a half. And if you just wanted to check it, well, let's see. Greater than a half is everything greater than a half. Greater than or equal to 1 just includes 1. So pick a number between 1/2 and 1. And if you pick 3/4, you get the summation 1 to infinity, 1 over n squared plus 1 to the 3/4. And there's different ways to do this, but again, if you think about it in terms of a comparison test and gearing yourself towards, say, a p-series, ultimately, forgetting all the expansion here, that would become n squared to the 3/4, that's n to the 6/4, which is n to the 3/2. If I plug that and that in, which gives me 1 over n to the 3/2, p-series I know if p is greater than 1, then it's going to converge, which means this will converge, so the one with 1/2 will actually work here. And it's only greater than a half because if you included 1/2, then if you think about it, this would essentially become squared to the 1/2, squared 1/2. If you expand it, again, that's not a perfect expansion, but the principle. Squared 1/2 gives you 1 over n, that's a harmonic series, which diverges. So again, there's the understanding of all the tests. I don't think I'm in frame right here, that's what these lines on the board are for. There's knowing all the tests, but assuming the test you're taking is multiple choice like this, there's kind of a basic understanding of what's going on, and you can kind of guess and check a little bit and skip all the really complex math. And I have to, like I said, I have to stay within those 2 lines on the end to make sure I'm in frame, so we get to erase all this. Next up, let's see, there were a few others. We're going to skip 25 for right now, because I don't know how long I can make this video. Which of the following series converge conditionally? So just to run through them. Remember, just to make sure you're clear, converging conditionally is when you're talking about alternating series, all of these are, and you can have conditional convergence or absolute convergence. Conditional convergence means the alternating series converges. Absolute convergence means if you take the absolute value of that series, it converges absolutely. So, let's see. For the first one, we have -1 to the n over n squared. And I would point out, does it converge? Yes. For alternating series, the terms are decreasing. It's essentially 1 over n squared. And the limit of the terms is 0, which means the 2 checks for the alternating series test, it converges. Does it converge? Absolutely. To do that, just take the absolute value, which in this case would give me 1 over n squared. That's a p-series, clearly convergent, so this one converges absolutely. And based on the way this is worded, which ones converge conditionally? I'm going to assume they mean they converge conditionally or absolutely. This one converges absolutely, so it doesn't converge conditionally. I'm assuming they're trying to draw the distinction between them. It does converge conditionally, but it actually converges absolutely. So it's a higher standard, and I'm guessing that's what they're going for. So this one is absolute convergence. The next one, -1 to the n over, and we have the summation, this doesn't really matter, but there's 2 to infinity of n over ln of n. And here, if you look at it, the ln can maybe be confusing. If you think about the series itself, it's alternating, so if you want to do the alternating series test, you're stuck with looking at n over ln n. Is that decreasing and does it approach 0? And if you're not all that good with natural logs and thinking about them because they can be confusing, if all I care about is the limit, then take the limit as n approaches infinity. That gives me infinity over ln of n is infinity. Then if I think about L'Hopital's rule, I get 1 over n, which becomes n. And as n approaches infinity, that approaches infinity, which means that doesn't actually converge to 0 at all. It blows up to infinity, which means this one doesn't converge at all. And I would point out, if you can't see that explicitly, the other alternative, instead of doing this, if you think about it, pick a few values for n. If n is, say, 10, don't worry about the negative, I don't care about that. I get 10 over ln of 10, which is a really small number, because it's 2 raised to like the 1 or something. Well, I'm sorry, it's like 2 raised to the 1, which means it's really big. Really, it's like not a decimal, I'll say it that way. Then make n like 100. Then I get, say, 100 over ln of 100. But again, ln of 100, what power of e will give me 100? E is 2.7. So maybe somewhere between about 6. And I get 100 over 6, which is an even bigger number. And the point is, it's pretty clear pretty quickly, this thing is not approaching 0, it's getting bigger, which means it doesn't even converge. Next one, negative 1 to the n over e to the n. And I stress, clearly alternating, but n over e to the n, linear on top, exponential on the bottom, it's going to approach 0. That will conditionally converge. But if you look at the absolute value, you get n over e to the n, which again is linear over exponential. It's absolutely going to converge, which means this will converge absolutely. The only thing, looking at the answers, since 2 definitely does not converge, and 1 and 3 do, the only possible question is, and this is based off of the wording, 1 and 3 converge conditionally by definition, but I would argue you don't actually say they converge conditionally, they converge absolutely, which means the answer is none of them do, because the second one diverges, the other two converge absolutely. Next up, we'll do a couple more for the next one. Which of the following series converge? N equals 1 to infinity. These are more alternating ones. N over n to the, really bad vision here, 1/4. Alternating series, so alternating series test, again, 2 possibilities. Do the terms decrease and does it approach 0? Ultimately, this is just 1 over n to the 1/4. Do the terms decrease? Yes, as n gets bigger, that gets smaller, so check. And is the limit as n approaches infinity 0? Yes, obviously, as n gets bigger, I get 1 over infinity, which approaches 0. 2 checks meet, which means this one converges. And again, I would stress, if you looked at the regular one, if you want to talk about, say, the last one, 1 to infinity, to check for absolute convergence, you would take the absolute value and get 1 over n to the 1/4. Here, that's a p-series. The p-value is less than 1, which means this one diverges, the positive one, which means this one converges conditionally, doesn't converge absolutely. And that's what I mean. I would assume on the last question, that's what they're going for. So the last one, the 2 that converge absolutely, they don't converge conditionally, even though it means they actually do converge conditionally. It's a higher standard. This one doesn't converge absolutely. It only converges conditionally because of the alternating series test. I'm going to skip the second one because I don't feel like doing it. But this one, n equals 1 to infinity, 4/3, 1/2 to the n. And I'll point out, because I did variations on this when I teach the class, yeah, you've got fractions there and all that, but ultimately you understand there's a difference between constants and the things that change. 4/3 is a constant, just pull it out to the front, and I get 4/3 times 1 to infinity, 1/2 to the n. This is now clearly a geometric series, which means geometric series, the ratio is 1/2, which is less than 1, so it's going to converge. And the fact that this is bigger than 1 or whatever doesn't matter. This converges to some constant, and then you multiply it by 4/3 and get some other constant. So this one converges. Let's see. And the last one, I'm trying to make this video not too long, so I guess I skipped a couple of them. I can do those again tomorrow if you like on a separate video. Let's see. Interval of convergence for the power series n equals 2 to infinity of 3 to the n x to the n over n ln n is, and you're given a bunch of values, and it's been a while since I did intervals of convergence, so this is going to be fine. But if you remember, for interval of convergence, the test is ratio test. So ratio test is the limit as n approaches infinity of a to the n plus 1 over a to the n. We need absolute values here for this. So for this, we get 3 to the n plus 1, x to the n plus 1 over n plus 1 ln n plus 1 all over 3 to the n x to the n over n ln n. And then I just have to reduce all of that. So let's see, I get 3 to the n plus 1 will cancel and just leave a 3. The green doesn't show up very well. I think this one does. I'm trying to find colors that you'll be able to see well. There we go, that should work. So I'm left with a 3. I have x to the n plus 1 over x to the n. And then I have n plus 1. Let's see, here, denominators flip and all of that. So to write this out neater, I have a 3 here. I have an x to the n plus 1. Now, the n from the bottom will come on top, and the ln of n will come on top. Then on the bottom, I'll have x to the n, and then I'll have n plus 1, and then I'll have ln of n. And then ratio test says this will converge if this limit right here is less than 1. Then you just have to solve that right there. And for the purpose of this, I left off an n plus 1 right here. For the purposes of this, ultimately, n over n plus 1 as n approaches infinity is essentially the same thing. So that will approach 1 as n approaches infinity. ln of n over ln of n plus 1, same thing. Ultimately, they're essentially the same. So this will approach 1. So I'm really left with 3 x to the n plus 1 over x to the n. But now x to the n plus 1 over x to the n, reduce that, I just have an x on top, is less than 1. And then solve this. X is less than 1/3. And if you remember from calc 2, there is a radius of convergence and an interval of convergence. I was checking. This one asks for the interval of convergence. What this means is this is your radius of convergence. So R, your radius of convergence, is equal to 1/3. Then you use that to get the interval of convergence. And in this case, looking at the original series, to make this as easy to remember, if you're hoping to remember very well as possible, if x is equal to 0, that thing will definitely converge. That's definitely my center right there when x is equal to 0. Then essentially I'm using my radius around that point, which means my interval will be negative 1/3 is less than x is less than 1/3. But if you remember, the radius is 1/3 for convergence. That says nothing about the endpoints of that radius, because that wouldn't change the radius at all. But to find the interval of convergence, I care about the endpoints, which means I let x equal those endpoints right there, plug them into the original series, and then see if that original series will converge or not. So, if x is equal to 1/3, I get x is equal to, I said 1/3. 1/3 to the n over n ln n. But that's 3 to the n, 1/3 to the n, which means that becomes 3 over 1/3. So that's 3 over 3, which is just 1. So that's 1 to the n, which is 1 over n ln n. And then you would check if that actually converges or diverges. And you'd probably end up for that one to check the convergence or divergence of that one. Which test could you actually use for that? If we apply the ratio test to this series right here, my markers are dying. Look at a to the n plus 1 over a to the n. Then I would get 1 over n plus 1 ln of n plus 1 over 1 over n ln of n. Simplify that, flip everything around, I get n, these will flip to the top, so n ln n over n plus 1 ln of n plus 1. But then, ultimately, like we said, that approaches 1, that approaches 1, which means the limit here is equal to 1. For the ratio test, convergence has to be less than 1. This limit is equal to 1, which means when x is equal to 1/3, this will actually diverge. Or actually, it will be inconclusive, but ultimately you'd have to use a different test, and I'm not going to take the time here because this is long enough. It will diverge, which means this is only a less than, because 1/3 doesn't converge. Then you do the same thing, you check this endpoint, negative 1/3, and you get the sequence, or the series, 2 to infinity, 3 to the n, negative 1/3 to the n over ln of n. Here again, you can combine these. 3 times negative 1/3 is negative 1 to the n over n ln of n. This is now an alternating series. For the alternating series, the two checks, if I look at 1 over n ln of n, does that decrease? Yes, clearly. As n gets bigger, this whole thing will get smaller. Is the limit of the terms 0? Yes, this is constant. Those get bigger, it approaches 0. The two checks meet, which means this thing approaches 0, which means by the alternating series test, it converges. What that tells me is it diverges when n is equal to 1, when x is equal to 1/3. It converges when x is equal to negative 1/3. So that's my interval of convergence. Negative 1/3 closed to positive 1/3 open. And again, clearly, if this is the framework of your test where it's multiple choice, there are some tricks you can do, plug in some values and see what's going on. There's an understanding of what's going on, and then there's all this little minutia, alternating series test and the conditions, radius of convergence versus interval of convergence, and all those little type of things like that, which frankly, you're never going to see again in any of your other math classes, I don't think. for the engineering classes you'll take. But for Calc 2, you need to know them. I skipped over a few of these because I think this is long enough. If you want me to go over the other ones, let me know. And like I said, I'll do that tomorrow and throw it up there because you said you have until Saturday, I think, to take the test. And like I said, I'll also send you a link to my videos on Taylor series and Taylor polynomials. And I'm sure Ms. Hirschberger will send you all of her stuff too.